So let's look at how to do input and output in Java. So in general, input requires us to read a sequence of bytes from some external source. So this could be a file, it could be the keyboard, what's called the console. It could even be, in these days, an internet connection. You might be reading a stream of data from an external website. Or you might just want to be reading data from some block of memory. Think of it as an abstract file and read from memory. So all of these conceptually are the same thing. You have something which is outside your program, which is feeding you a sequence of data, and in a raw form, the sequence of data is a sequence of bytes. And symmetrically, you might want to write, right? So you might want to send out data to a file or to an internet connection or to a block of memory or onto just the screen, for example, right? So Java refers to this process of reading and writing sequences of bytes as input and output streams. Now this is a somewhat perhaps awkward use of terminology, because we have just been studying a very specific type of streams, which is this class stream, which is a kind of sequence of values which we can then process by passing it through a number of filtering transformations. So even though there is a similarity, you can think of a sequence of data coming in and out as a stream of data, but technically the word stream in the context of input and output streams is not quite the same as the word stream in the sense of the previous discussion on Java stream class. So one of the big problems with input and output is that we have to interpret this data, right? So in a raw form, all data is written in the form of binary zeros and ones, and usually it's packaged in bytes, which are 8 bits, 8 binary digits. But whether these 8 binary digits or groups of 8 bytes, like 2 bytes or 4 bytes or 8 bytes together constitute a character, do they constitute an integer? Is it to be written sort of as a floating point number, right? So we have to do this transformation to decide whether to interpret these bit sequences, these bytes that we read in these input-output streams, as meaningful data. So one way to do this would be to have a different operation for each type. So supposing you want to read data from a text file, then you have a function which reads text information from a file. You want to write binary data to a network connection, then you have a separate function which writes binary data only to network connections. So this would mean that for every combination of input and output source, and every type of data that you want to read, and every other transformation that you want to do, you would have a different way of invoking the function. So Java has a slightly different approach to this. It tries to modularize this process into the different components. So at the raw level, you would have something that can read and write bytes. Now you can read and write bytes from different external sources. So there is a separate component which allows you a separate IO stream, as it is, which allows you to connect an external device like a file or a network connection as a stream from which you can read bytes. Then you might want to transform these bytes and read them as text, read them as binary data, and so on. Right? So by building this kind of a pipeline of these IO streams, you can build a transformation which takes a source, converts the bytes into a meaningful form and processes it, and in the reverse direction takes a meaningful data, converts it back to bytes and writes it. So at the raw level, we read and write bytes. So these are described in the Java classes input stream and output stream. So if you look at input stream, it gives you some methods to read bytes. So the most abstract of these, which is actually not implemented directly by input stream but is concretized by subclasses, is called read. Now you notice that it reads a byte but it actually returns an int, and the idea is that it usually signifies a -1 if there is a terminating condition. So that's why it's an int. Now you could have more generous reads, like you could read into an array of bytes, and this will return to you the number of bytes that were read. Or you could read the entire input stream as bytes into an array of bytes. So there are many more. These are just a few examples of the kind of input read functions which are available in input stream. So for example, when you try to read and something is not available, then you have to wait. So this is technically called blocking. So the program will wait, or it will block until the data is available. So if you want to be sure that you are reading data that is available, you might want to check in advance. So there is a function that input stream class gives you called available. So if you have an input stream, then you can invoke available on that input stream, right? So on in, and it will tell you how many bytes are currently available to read. And then you could use this form of the function which reads into a byte array by checking if you have a non-zero number of bytes available, then you can read into a byte array of that size. So this is a way of combining the different components of input stream in order to read. So symmetrically, you have an output stream class which gives you these abstract and concrete ways to write data. So you can write a single byte, right? Or you can write an array of bytes and so on. So for example, here is a situation where you have an array of bytes and you write it out in one shot. So one of the things that has to be done when you're dealing with streams is you are really connecting at some level an external resource to your program. And so underlying this, there is some mechanism which has to be invoked in order to do this. So there are some other things which have to be done to make these streams connect to each other and connect to the file or the network or something. So in order to signal to the system that this connection is no longer needed, you should always close a stream once you're done with it, right? So close is a function which is associated with streams, which returns the resource that you're using to do your input and output. The other thing that happens normally with output in particular is that the output is not written as soon as you write it, it doesn't go to the target. So typically it goes in batches. So you can imagine that it's like, for example, a delivery truck, right? So if you want to deliver stuff, what will happen is that you will first load up the truck, and when the truck is full, it will go. Or if you have seen some of these buses waiting at a bus terminus, right? So the conductor will keep waiting for passengers to fill up, and only when all the passengers fill up does the bus leave. So in the same way, when you write output, only when the output has filled up to a certain length, which is called, so it writes into what is a temporary space, which is usually called a buffer. So this output is buffered. So when you say print, for example, it doesn't automatically print on the screen. In fact, if you monitor a long-running program and you have written some diagnostic print statements and you don't see them on the screen, it doesn't necessarily mean that that print statement has not been executed. It just means that it has not passed the buffer and come onto the screen. So the way to push things out of the buffer forcibly is to flush them. So if you really want the information that is in the buffer to go out immediately, then you can call flush. So close and flush are two operations which are not directly related to putting out specific data, but to making sure that you have released the resources or you have emptied out the buffer of pending writes. So this is as far as reading and writing raw bytes are concerned. So the first thing now we want to do is to make sure that our stream is connected to an external source, because we really don't have any input and output within the program. We have to talk to some external thing, and this external thing could be a file, as we said, or an internet connection, or even some place in memory. So in this class, we will just limit ourselves to dealing with files. So here is how you would construct an input stream attached to a file. So you pass as a string the name of the file. In this case, it's just a simple name, but you could give a path where it could find it on the disk on which your your program is running. And then you ask for a new file input stream which opens to that file. So basically, henceforth, this input will take input from that file. And of course, it will be assigned to this variable which we have called in. So symmetrically, you can create a stream which outputs to a file. So as you would expect, the input is replaced by output. So you get a new file output stream. And once again, you provide a file name. So now anything that I write to the stream out will actually go into that file. Remember, there is this buffering thing, so it will not go immediately. It will go in chunks. But everything that is written to the stream out will actually land up in that file, because this is an output stream connected to that file. Now input is clear. When I read input from a file, the file is there, I read, I start from the beginning and I go to the end. But output, there is an ambiguity. What if the file already exists? Supposing there is already a file called output.bin and I start opening it for writing in this case. What does it mean? Does it mean that I'm going to replace the current thing, or I'm going to add, that is append to the current file? So both are possible. So when you create this output stream, there is an optional second argument. So there is a different constructor. So the default is that you replace. Right? So the second constructor essentially second argument tells you whether you want to append or not. So this is really answering the question, is it an append? If append is false, it means I'm going to overwrite. So if I don't say anything or if I write false, then this will create a new output file. Okay, I've indicated by giving it a new name, but even if there was a file called new output.bin, that file will get overwritten. On the other hand, if I say true, then it means that I do want to append. So if I already have a file called same output.bin, it will start writing at the end of the file. But it is not going to insist that the file exists, obviously. So if there is no file, it will create a new one. It's just that if the file exists, then it will append. So you can control whether you're overwriting or appending when you open an output file stream. So now we have seen how to abstractly read and write bytes which are uninterpreted and how to connect a stream to a file. So you could take that file stream and apply the read and write function and you will read and write bytes from a file. But normally reading and writing bytes from a file is not terribly useful. What you want to do is interpret those bytes in terms of the data that your program manipulates. So one of the common things that you want to do is to read and write text files. So let's see how to read and write text files. So in the very first week or the second week of the course, when we discussed Java for the first time, we talked about basic input and output in Java, and we talked about the console class and a scanner class, and we talked about attaching scanner to a system input stream, which is essentially your keyboard, called system.in. So the scanner mechanism actually works for any input stream. So recall that we could have created a file input stream connected to this file. So we can now take that input stream and in some sense pipe it to a scanner. So this is taking a stream which is connected to a file and connecting that stream to a scanner. So you can also do it directly. You can start a new scanner in which as an argument you directly create the file input stream without naming it. So once we have done that, then this scanner input stream, we have already seen it in a little detail right at the beginning, but we can see it in more detail now, has a number of methods to read text data from the input stream. In this case, it's connected to a file, but logically, if we had connected it to some other device like a website or something like that, it will be reading from there. So the scanner doesn't care where the data is coming from. It's coming to it in a stream from somewhere, and that somewhere was supplied to it as a stream, right? So now if I read next line, for instance, then this is text data, so it will read one line up to a new line character and store it as a string and return it. If I just say next, it will give me the next word, right? So next word is defined by default by delimiting it by a space or a new line or any white space. Actually, you can change that delimiter if you want, but we will not get into the details. Or you could read the next integer, which will directly return, it will parse and return an integer to you. And if you remember how input works in Python, you only read strings and then you have to explicitly invoke an int function to convert it. So here in some sense is reading a string, converting it to an integer and then storing it as an integer. And then you can also check whether there are any more words. So this returns a boolean, true if there is a word still to come. So it's like an iterator, right? Remember this has next. So is there one more word to read or not? So once you have a scanner class, then an object of scanner class can invoke on its input stream a variety of methods to read text data in different formats, either as a string or as an integer and so on. So symmetrically, the simplest way to write text data is to create what is called a print writer. So again, you have a stream already given to you. Usually it is an output stream attached to a text file in this case. And on top of that, you build a print writer. And as before, you can create the print writer directly by passing the stream constructor as the argument to it. You don't have to separately create the output stream and then pass it to the print writer. And just like the scanner class had various methods to read, the print writer has different methods to print, but these are the methods that we already know. So remember we have been writing all along system.out.println, right? So all of those functions that we associated with system.out are actually the same functions which are available to print writer. So I can take a string and I can write to this print writer stream that I've created, I can say pout.println message. So it will print it and put a new line character and so on. Right? So we have these read methods and these print methods. So let's put that together. So supposing I want to take a text file and make a copy of it, right? So say I have some input.txt and I want to make an output.txt. Then from the previous discussion, you will first create a scanner object out of the file input stream connected to the input file. Then you will create a print writer object. So this is print writer. You will write a print writer object out of the output stream connected to the output file, outfile.txt or whatever. And now you can use this has next to keep reading lines as long as the input file has lines. So long as the input file has something to read, you read the next line and you print it out to the output, right? So I'm just copying from input to output. So this is a very simple program which just illustrates how you would use this input and this output mechanism in order to read text and write text. Now this program is deceptively simple because actually all these methods which are available in this IO stream business in Java carries a burden of throwing a lot of exceptions, because it is very common in such situations to have exceptions, because the file that you try to open may not be found, then when you're trying to write something the disk may be full and so on. So every one of these things will actually end up having to be inside a try, including opening a file. So when you write this, it will typically, if you just write a naive function to do this, Java will initially complain about various exceptions that you are not handling. So you will have to look up the documentation to figure out what is the most optimal way to write this code with the appropriate try blocks around it. So this is as far as reading and writing text. So remember, we had this file input stream, file output stream, and we wrapped a scanner and a print writer around them. So what if instead we wanted to read it as binary data? Supposing we have actually written 4-byte integers as raw data onto a file. I want to read and write such data. So here, instead of scanner, we use something called a data input stream. So it's a different class, but the mechanism of setting it up is exactly the same as scanner. You start by creating a file input stream and then you wrap a data input stream around it. So this is the way in which Java has modularized this process. So you have the same process for connecting to a file, and now you take the output from the input from that file, and whether you want to read it as text, use a scanner. If you want to read it as binary data, you use a data input stream. And since this is a data input stream, it will allow you to read raw data in the different formats that are available in the scalar data types of Java. So you can read an integer, you can read a short, you can read a long, you can read a float, you can read a double, and so on. So instead of just reading text as you would in a scanner class, here you will read raw data and put it into the appropriate data type in one of the built-in classes, built-in data types of Java. So again, symmetrically, instead of the print writer class, you have a data output stream class, right? So you again create a file output stream and wrap a data output stream around it, just like earlier you created a file output stream and wrapped a print writer around it. And once again, just like you had various methods to read raw data, you have various methods to write raw data. So you can write in short, you can write characters, you can write byte, you can write boolean. So you need to look up the documentation to figure out exactly what some of these mean, like write UTF is, what does it mean, and so on. So just like we wrote a small loop to read an input text file and write it to an output text file, you can do the same thing, right, to copy a binary file. So again, you would wrap a data input stream around a file input stream. You would wrap a data output stream around a file output stream. So you would set up this in and out. And now we go back to that thing we mentioned earlier, the raw byte input, right? So here we are just copying, so we don't want to interpret. We don't care what it is. We just read a byte, write a byte. So we check, first of all, how many bytes are available to read, right? And while this is greater than 0, we read all the bytes that are available into a data array, right? So we read it here, we write it here, and then we again check how many bytes are available, and we keep going until the number of bytes available is 0, right? So it may happen that it all happens in one chunk, it may happen it happens in multiple chunks, we don't care. As long as it keeps going until it says no bytes are available, you're going to faithfully copy all the input bytes to the output bytes. Since you're reading and writing them as bytes, you're not really interpreting them, you don't care. You could do the same thing in terms of integers and floats and so on, but here we're just doing a raw binary copy. So these are two of the basic things that one can do with streams, right? Connect them to a file or some other output source, and then read the data as text or read the data as some binary format which is meaningful for the built-in data types. But there are many other aspects of streams which we can consider. So the first thing is that we talked about output streams being buffered. So an output stream is buffered means that first when I write something, it fills up this thing and only then it gets written. Right? So there is a lag between filling up the buffer, and so this is the bus getting full and then it takes off when the bus is full. So the same thing can be done on the input direction, right? Instead of reading one thing at a time, right? So imagine that you are in a supermarket and the shelf becomes empty, right? So if somebody comes and asks you for a toothpaste and the shelf is empty. Now you could go into the storeroom at the back and bring one toothpaste, but you would not do that. You would typically bring out a bunch of toothpaste. So you will bring out a box of toothpaste because then you know that later on more people are going to come and ask for toothpaste. So you will save yourself multiple trips by doing it in one shot. So same way you can read data also in chunks. So if I only want to read one character, eventually I can assume that I'm going to read more characters. So I can read a chunk of data because when I read there is a certain size of data that is automatically available to me. But how do you indicate that such a facility is there in Java? Well, you can create explicitly a buffered input stream. So by default, a file input stream is not buffered, okay? But now if I create a buffered input stream around it, then the data is going to be read more efficiently. That's all. It's not going to change the data, it's just going to read it more efficiently. And I can now take this combination. So I've pipelined it. I've taken a file input stream, put it into a buffered input stream. So now the data from here is being buffered, and then I feed it to a data input stream so that I can interpret the data as binary data. So this is the kind of thing that can do with buffers. Another thing that you can do is to examine something which is available in the stream without consuming it. Okay, so when we looked at a long time ago in collections, we looked at these peek methods when we could look at the top of the stack or the front of the queue and then not read it actually. So the same thing we can do with what is called a pushback stream, right? So we can take this buffered stream and then we can further layer it as a pushback stream. So now in this pushback stream, I can read something and then check its value, and if I don't, I mean depending on whatever the value is, I can either consume it. So if I read it, it has been consumed, right? Or I can unread it, put it back, so hence pushback, right? So I can read it, look at it and then put it back. So one thing to remember is that these things are designed for minimal functionality. So a file input stream can only connect to a file, it can't read anything. A scanner class can read text, but it can't connect to a file. So each of these streams that we have discussed does one thing or one type of thing and not many types of things. So here a pushback stream can only read and push back, right? It can't do anything else other than read and unread. So if I then want to take this data that I have read and unread and interpret it as some binary data, then I must take this stream and create a data input stream on top of it. Right? So before I invoke the data input stream, I use the pushback stream to check whether the data should be passed to the data input stream or not. So if I unread it, then it goes to data input stream. If I read it, the data input stream will not see it. Right? So in this way, Java separates the concerns. Right? So there is a whole zoo of streams. Right? So we have looked already. We have seen some 5 or 6 different types of streams in this small lecture, and there is actually a whole collection of streams to deal with a variety of tasks. For example, files. The files we have been talking about are what are called sequential files. When I read, I start at the beginning and I go to the end. So I cannot vary where I am going. I have to start at the beginning, go to the end. Similarly, when I write, I start at the beginning, go to the end. So what if I want to read from the middle of a file or write at some place, not at the end, not append, but write somewhere in the middle of the file. So these are what are called random access files. I might want to say at the 1000th byte, go and write something, or read from the 700 byte onwards. So Java has a separate random access file stream class which allows you to do that. What if the data is somehow compressed, supposing it's in some zip format? Then I have to unzip it in order to make sense of it. So rather than unzip it separately, Java will actually allow you to read the zip data directly and transforms zip data into unzipped data. So for example, if I want to read binary data from a zip file, so first of all I will construct a file input stream connected to the zip file. Then I will layer a zip input stream on top of this, which will take the data from that file input stream and unzip it and put it out as unzipped data. Now I can take the unzipped data, which is now readable, and interpret it using a data input stream. So by combining these components, you can put together these complex combinations using a relatively small number of objects. So the number of permutations and combinations of these objects is very large. So rather than confronting you with a zoo of high-level functions which combine all these functionalities, the option that Java has chosen is to give you a smaller set, not small, but a smaller set of low-level things, each of which does a specialized thing, and leave it to you to assemble them as you would see fit. So the basic approach that Java has taken to input and output is to separate out the concerns, right? So you are supposed to take these different input-output streams and chain them together according to your requirement. So at the basic level, you want to connect it to some different external source for input or output, and it doesn't really matter once you've connected it for the rest of the processing, whether it came from a file or it came from a network device or it came from a memory or something else. Then at a raw level, these things transmit bytes, but you can take these bytes and interpret them as text, you can interpret them as data. They could be zipped, you could buffer it, you could check and unread, you could do speculative access. At the file level, you can do random access, right? So by doing all this, at one level, it seems that to do anything basic, if I just want to read a text file, right? It seems so much simpler if you just gave me a single function which will open a text file and read it, like in Python, right? We just open a file, read it and close it. Whereas here we have to set up the file stream, then we have to set up a scanner class, and then we have to call functions on that. But on the other hand, by doing it this way, though it appears tedious, you have this flexibility, right? You can combine different sources with different types of data interpretation very flexibly. So it's a trade-off, but in the long run, having these different parts which you can put together as you see fit gives you a much wider range of options than if you're just given a fixed set of functions which work with fixed types of inputs and fixed types of data.